We have two great speakers today for our event. Hugo Phan, who is Technical Marketing at Atlantis, who is a VMware VCDX and a vExpert, as well as Jim Moyle, who's a Citrix CTP and the Global Subject Matter Expert for Workspace at Atlantis. With that, Hugo, I'd like to hand it over to you.
Thank you, Michelle. So yes, thanks for joining everyone. Today we're going to be speaking heavily about why IOPS and latency are important in your Windows 10 VDI projects. We'll be brushing along the lines of, for example, what to expect when you're planning a Windows 10 VDI project. What are the key applications that will require the necessary IOPS and latency? For example, we'll be looking into what Microsoft Office 2013 has an impact on your VDI estate, especially when it comes to launching applications, running Outlook, for example, PowerPoint, and so on. We're looking into the effects of antivirus software, what kind of impacts that has on your environment, and of course also Windows Update. We'll be talking about how to measure performance of your Windows image. So, what tools to use, how to test at scale as well. And we'll be looking at the key demands for performance in a Windows 10 virtual machine, and also what's required in Windows 10 for VDI. So we're looking at the pitfalls, the gotchas, and so on. We know that Windows 10 and IOPS are the most challenging, least understood, and most frequently encountered resource bottlenecks. So hopefully these points that we'll be covering will help you understand and plan for your VDI project better. So with that, I'll hand it over to Jim, who'll give you an insight into the Windows 10 today.
Thanks, Hugo. So me and Hugo will be swapping over during the presentation. I'm the one with the odd accent, and Hugo's the one who sounds much clearer, so you can tell the difference between us pretty easily. So, Windows 10, why now? It's just really starting to come up in terms of the conversation that I'm having with customers and in the community about Windows 10, about looking into it. And the main areas where I see uptake of Windows 10 or a lot of chatter around Windows 10 right now are sort of three areas. One is education, primarily because in that vertical, because of the age group of their users, they're looking to present something that's modern, something that they'll know, rather than looking sort of old-fashioned as they bring that age group on. So in terms of actual complete deployments or people who are in the throes of it, that's the main sort of people that I see who are looking at Windows 10 in terms of a vertical. Second lot of people is where touch is important to them. Windows 7 will never be good at touch. So effectively, if you for some reason have given tablets or that use case, or you have touch-enabled applications that you wish to give out to your users, then Windows 8 or Windows 10 are the absolute necessity, because Windows 7 will do. And the last one is very, very large enterprise. Now, you think that these people would be the worst offenders when in terms of desktop refresh, and they are. They absolutely are. The problem is that for them, it takes so long to do a desktop refresh project. They need to be starting to think about it, and think about it seriously now. So those are sort of areas and groups of people I see looking at Windows 10. Now, does that cover most people? Well, no, it doesn't really. And in terms of where the movement to Windows 10 is going, I see a lot of people who are essentially hanging back, because Windows 7 is well known, it's deployed, it's trusted, and people essentially know what they're doing with it, and they know that they've got a little while yet to make their minds up about what they're doing. And I think for most enterprise, essentially you're going to have to pry Windows 7 out of their cold dead hands, because they'll hang on to it the same way that people hung on to XP. And fair enough, I can see why, because it's long and it's expensive, and the business value for changing your desktop OS is pretty thin, really. So what benefit do you get for spending a lot of money? So most of these people, I believe, are going to wait till the last minute to go and change. What's the last minute? Last minute is right here, 14th of January 2020. This is the end of extended support for Windows 7. And I believe that we'll get a massive flurry of projects and people scrambling to get there before Windows 10 runs out of extended support. Same as we did for Windows XP. I don't believe that people will have learned the lessons from there. People will think it's a simple thing, and it won't be. It will be much harder than they thought. Now, Windows 7 actually went end of life 18 months ago. So this is one of the reasons why I say Windows 7 will never be touch enabled, because Microsoft will stop releasing new features for 7, 18 months ago. It's only security updates now until this date. So this date will become burned in people's brains as time gets closer and closer. So what are people doing? Essentially, they're dipping their toes into Windows 10. They're seeing what the pitfalls are. They may be running some proof of concepts. They've maybe got a small subset of users they're thinking of providing Windows 10 to, and essentially just scoping out the size of the job in front of them around Windows 10. And we're going to try and help out with that in terms of some of the gotchas in the projects that we've already done, and what we've learned in terms of testing and sizing, in terms of resource constraints around Windows 10. Just to touch on stuff that isn't really relevant to Atlantis, isn't really relevant to storage, but some important things to bear in mind that we found out along the way. Around a couple of things really, it's modern apps and security. Now modern apps are really interesting because these are completely, or universal apps or whatever, metro apps they used to be called. These are unusual because there is a completely different way of both deploying and updating modern apps, completely separate from the usual Windows update mechanism. So these just update whenever Microsoft say that they're going to update. You have no control over it. So that means that for an enterprise IT admin, this is quite a dangerous thing. And surprising things are modern apps. The Edge browser is a modern app. The lock screen is a modern app. Now, the lock screen is important because depending on what version of Windows that you have, depends on whether you receive advertisements from Microsoft on your lock screen in Windows 10. Now, if you have professional edition, then you're not supposed to receive advertisements. That has gone wrong in the past, and people have done. Not a good thing for the enterprise. So really think, okay, that's fine, I'll just turn them all off then. That's a bit trickier than you thought. Now, some of them, you know, Candy Crush or whatever, there's a PowerShell commandlet to go and turn those off. But the system modern apps, like Edge, they can't be turned off with PowerShell. In fact, you have to do a real weird kludge around those. And in fact, you've got to turn those off by doing odd things like renaming the directory, not deleting, that won't work, so it'll just get deployed again, but renaming the directory that they live in to get rid of them. If you decide you want to keep Edge and don't want to disable it in your desktop, you cannot set the home page. And this is the security aspect that I was talking about before. So Microsoft are trying to be very careful around malware. And one of the most effective vectors for malware authors to come and take and get themselves in front of somebody's eyes is effectively change the home page, right? So with Edge, there is no possibility right now for the enterprise to preset the home page. It has to be done by the user. So if you want to have, as most enterprises do, you know, a different home page for this subset of users or that home page, then it has to be an IE, can't be an Edge. The other aspect of security that makes our lives pretty interesting in Windows 10 are file type associations. So if you're doing VDI and you say, right, well, I want to have this subset of users using Acrobat Reader, but this subset of users using the full Acrobat suite. Well, now in Windows 10 we can't set that because, again, file type associations were a vector of attack for malware. So again, these are only settable at the user level without some very, very interesting kludges, and if we can talk about those separately. If you want to shoot me an email, we can have a chat about that. But there are some very interesting things in terms of enterprise control of Windows 10, which you'll find interesting if you're expecting the usual GPOs, the usual admins to work with Windows 10. So we've got a poll now. So I want to see, we've got a lot of people on, so let's have a see, where are you in that journey to Windows 10? Are you just starting? to go on that journey? Have you already done a big project? Have you seen some of the problems that we've just been talking about? Have you got over those problems? So we'll leave that poll open for you guys to answer, I think, 4 or 5 questions, and we'll show the poll afterwards, and we'll see where we are in terms of where you guys are in that journey. All right. So we're looking like 42%. We're just looking at Windows 10. So as sort of predicted, we're looking at the people who are just dipping their toes into whereas interestingly, we got 5% people who say they're on Windows 8. That's brave. And 15% saying we've already moved to Windows 10. So interesting results there. Now, particularly, I was surprised to see that we got so many Windows 8, because the only people I know who are on Windows 8 are effectively people who are stuck on the wrong cycle. And they're people who moved to Vista from XP, and then had to move off Vista to something else before Windows 10 was available, and then had to move to Windows 8 essentially. So I don't see that as a big section of the market right now, so I'm quite surprised to see 5%. Now, whether those Windows 8 people are looking to hang on to it or move to Windows 10 in fairly quickly, that'd be an interesting question as well for people to have a look at. So now we know the gotchas. Some people are new, have already moved to Windows 10, you're already good. Is it all plain sailing from here? Well, that's sort of internal and to the architecture. What we're looking at now is stuff that's external, right? The resource constraints, the storage, etc., the networking, etc., etc. Now, there's been lots of pretty pictures so far, and that's all very nice to look at. Pretty pictures are going to go away very shortly. We're going to be looking at a lot of graphs. Now, I like a graph as much as the next one, probably more than the next one, actually. So we'll get a bit more technical after this. Now, I think Hugo's going to talk a little bit more about the tool set that we've been using, particularly in terms of storage, to do the testing for the white paper, particularly under Windows 10.
Thanks, Jim. Yeah, some really interesting results from that poll there. I mean, one of the questions or comments that came up was, why didn't we have one for currently on Windows 7 but looking at Windows 10? So I think we can take that 42% result with a pinch of salt and assume that the majority of those people are already on Windows 7 and are looking at Windows 10, which is quite almost half the number. So that's really interesting from my point of view. But I do feel sorry for those who are currently on Windows 8, as Jim said. So anyway, let's move on, talk about the tool sets and what tools to use to test your environment. Now, you know, the pretty slides are all going to disappear from here. This one is kind of half pretty. I quite like it. But if you look at the slide, it's like, you know, the whole point is quite a lot of tools, right? So what do you use? What's the right tool for the job? In some instances, you know, you can use a hammer to drive a nail, but occasionally it's actually much better to use a screwdriver to screw something in. It's much more accurate, much more graceful. So let's look at, you know, what to look for when you're, you know, trying to test your environment out. So you can measure how IOPS are delivered, for example, by using just simply the performance monitor within Windows 10. So what key items do you need to look for, right? So in there, you can look at disk reads per second, which is read IOPS, disk writes per second, which is write IOPS, and disk transfers per second, which is total IOPS. Now, the only problem with this is this gives you the performance for an individual VM, right, running on your storage. So if you're running this on a physical desktop, you'll see the performance of that individual physical desktop, which has its dedicated disk, which could be just a normal, you know, 5,400 RPM drive. If this was a VM, then it would be the performance of a single desktop VM on your entire storage infrastructure, which could be backed by a NAS or SAN. Right, so it's very, very, I guess, limited by that single instance. Okay. So, but the graphs give you an indication of the demands for that desktop. Now you can then export that data and then output it into nice graphs, into Excel, for example, and manipulate the results. So how do you go about doing more than that, right? So using more of a, let's say a hand screwdriver approach. Next best thing, so you can also look at the performance results from your hypervisor, right? So I'm using ESX as an example here. Just using ESX top, logging into the hypervisor and then using the U switch to the device storage mode. And here you'll see commands per second is total IOPS with the equivalent write and read highlighted to the right. Okay, and on the far right we have GAVG commands, which gives us the latency. So this is showing the current latency and IOPS that NFS share, 100 Smoky, is currently being seen by this individual ESX host. So this is a little bit better than the performance monitor in that it shows you the total IOPS and latency seen by ESX server on that NFS data store for all the desktops running on that NFS data store on that host. Right? So I hope you got that. So a little bit better, but not really ideal. Okay, so because that's just limited to that host and that data store. Okay, so how can you do this to see the IOPS or latency for a particular storage device? So the next piece of equipment that we have is, of course, IO meter. Now, IO meter is an interesting tool. You have to configure it properly, and if you want to know how, then just Google Jim Moyle IOPS, right? And that will come up with some results with, I think, the top two, which shows you how to configure your IO meter profile to look at the performance of your storage. So here we configured it against the USX data store, and that USX data store, just a single USX data store with multiple workers on that VM, will get you about 60,000 IOPS, which is pretty good. I won't cover everything here. You can read the white paper or just Google that, and that will give you some of the results to try this in your environment. So the great thing to do is run this profile against your current environment today. So if you're running Windows 7 desktop VMs on some NAS arrays, run that, and it'll show you what kind of performance you're getting. Jim will go into the differences between Windows 7 and Windows 10 later, but if you do this, it'll be quite a good indication to show you what kind of performance you have. All right. Now, the only bad thing about IO meter is it shows you the performance of seen from a VM to this underlying storage tier. So there's no way of understanding the end-to-end view of your VDI environment. So how do you go about doing that? Well, we use a tool called Login VSI heavily internally. So Login VSI is an awesome tool. I think it's considered the industry standard, right, to create real-world VDI workload generation. If you go to Login VSI website, you can actually download a free evaluation copy for 100 users, so you can run tests at scale for up to 100 users. And the tool simulates accurately real-world experiences of a user. So you can do different kinds of users, knowledge workers, for example, and you can configure the actual workload. So whether you do PDF file creation, you do compression on zip files, you do Office 2013 or Office 2016, and Login VSI also supports Windows 10, which is great. So this is what we used here. So the key thing around Login VSI is it allows you to test your whole entire environment, right? So the experience that a user would see from a desktop point of view at scale. So you can see that this graph here, we've launched around 1,500 sessions. All of this is, of course, against a Atlantis USX backend. So this shows you some of the value of USX. And the VSI base is 765, which is quite low, right? So these are being validated by Login VSI, for example. And the whole objective of the Login VSI test is to keep those numbers as low as possible. So we've got a VSI average of just around 1,000 for 1,500 VMs, which is pretty good, considering the types of storage that we have that we come up against in competitive situations. This is kind of performance you'll see on Atlantis USX or Hyperscale. Jim, do you have anything to add here, dude?
Just a couple of things. I mean, as I said before, I like graphs, right? And VSI graphs are interesting. With quite a lot of infrastructures, you'll see that this graph very quickly sort of hockey sticks up into very, very poor performance as you load up with users. And one of the nice things about having a truly scale-out architecture is it means that we can make sure that that hockey stick doesn't happen, and we scale out and keep that baseline and that average as consistent as possible. And consistency is what you need, right? Whether you've got your first person coming in at 9 a.m. or their 10,000 colleagues are in by 2 or 3 p.m., you need to have that consistency of user experience across the day, across the week, across the month, etc., etc. So, on the topic of login VSI, so we work really closely with the guys at Login VSI to both validate all of our testing results, but also we use it internally for scale testing, for QA, etc., etc. They've just recently released a white paper with a lot of detail on Windows 10, and they're very kind enough to lend me some of their data that they allowed us to represent here. If you want to go and have a look at their white paper, then go to loginvsi.com or the hashtag VDI like a pro. So let's look at the difference in Windows 7 and Windows 10. Now this is what I get asked a lot actually. So I've got Windows 7 now. What's going to happen to my infrastructure if I change all those desktops to Windows 10? How much more storage, RAM, CPU, etc. am I going to need? Now we're going to concentrate a little bit on storage for obvious reasons in this one, but the white paper that VSI have, I've got the rest of the stuff in as well. Now if we're looking at a default install, so this is an untuned install, and we're looking at Windows 7 in blue versus Windows 10 in orange, and we're looking at IOPS as those VSI tests are ramping up, we can see that they're pretty similar actually. And this sort of makes sense actually when you think about it, because although there's a lot of difference between 7 and 10, the main file system is exactly the same. So NTFS has not had a lot of changes underneath 7 and 10. Obviously there is a new file system, REFS, but that's for specialist uses, and you're not going to see that underneath Windows 10 anytime soon. So if we know that the total amount of I/O that's been generated via Windows 10 is about the same as Windows 7, is it the same read-write percentage? Are we seeing that 80% write, the 20% read that we saw in Windows 7? So if we have a look at this, is reads per sec, Windows 10 and Windows 7, broadly similar. Now we can see that again, because they're broadly similar, very little changes between 7 and 10. We see that 10 is above here. I get informed by VSI that's sort of within their error margin. And writes per sec, again, broadly similar. So what we're talking about is if you're talking IOPS on your storage and you want to know if I move to Windows 10, will I have to increase the number of IOPS on my storage if I'm happy with the IOPS I've got now with Windows 7? And the answer is no. The answer is actually you should be fine. Now, this is just with the same apps, yeah, on the same hardware. If you're changing your apps, so if you're revving the version of your app, so you're going up to the latest versions of Office, if you're taking this opportunity to go from a 32 to a 64-bit version of an application, etc., etc., that's going to change this picture. And it's quite often going to change this picture quite radically, and you then are going to have to account for extra resources, both in terms of storage and RAM and CPU. So we're just really talking about the underlying OS with the same set of apps here. There is a difference though, and this the guys tell me is consistent across it. The throughput is actually quite a lot greater for Windows 10 over Windows 7. So actually Microsoft's done quite a good job here. So they've realized that they are actually needing to write more data, but they've managed to do it in such a way that they're not causing more IOPS, effectively by increasing the block size, the average block size of Windows 10. So they've managed to increase throughput without increasing IOPS. Now, if you're talking purely storage, then throughput is usually less of a problem than IOPS. Talking networking, obviously, throughput then starts to become a bigger issue. So if you're looking at, for instance, a PVS deployment of Windows 10, it may be the case that because there's more throughput down to the disk, you're going to need more to and from the disk, you're going to need more network infrastructure to be able to cope with this. Not a massive amount, but if you're already on the edge, then it's definitely something to watch out for when you're looking for 10 versus 7. Now, and that's just on storage and throughput, on IOPS and throughput and storage. One of the nice things about logging VSI, right, is that it tests your entire infrastructure. So this test is, again, untuned, all of these been untuned, against the density, the total density that you're going to get on the same hardware with the same outsets. And so this is not just storage, this is RAM, CPU, all the rest of it. And it turns out that you actually get a lot, well, not a lot, but a little bit less density when you're talking about Windows 10 over Windows 7. About 12.5 to 15% less density Windows 10 to Windows 7. So that means that, you know, if you've got 1,000 users on Windows 10 on, you know, a cluster of blades, then you're going to need to provide an extra sort of 15% of hardware to be able to get the same number of users at the same user experience than you had previously. Now, as I said, all this is defaulting, so what happens when you tune it? So you can tune 7 and you can tune Windows 10 for a virtual desktop environment, and you should be doing. All the vendors have tuning applications which go away and turn off services, etc., that you don't need. Now, you actually see the same result. So if you've got a heavily tuned Windows 7 environment, hopefully you're going to tune your Windows 10 environment as well. But again, you're going to see about that same amount of difference in sort of 12.5 to 15% less density on Windows 10 than on Windows 7. Just on those tuning applications, like I say, all the vendors have one. I actually like VMware's one of the best. I think it's the most comprehensive in terms of what they cover and the most powerful. Be careful when you use it though. It is very powerful and it does do a lot of things. Be careful that it doesn't break your image. I have seen a few people who've just run it blindly and it has done awful things to their image. So if you are running these, and this applies to any of the tuning applications, right? Be careful that you're looking at exactly what it's doing, and be careful that you know exactly what it's doing. Otherwise, you could end up with issues.
For example, the Windows indexer, right, Jim?
Yeah. So the indexing service. So I use search all the time. I live in search boxes because I don't store my emails in nice little folders. Can't be bothered with that. I use search. Turning the index off would actually cripple my user experience. I would hate it. Indexing requires lots of I/O. Some of these tools will turn indexing off by default. This isn't an optimization. This is a cost-saving exercise to make sure that, you know, your storage costs are lower, and would be for me crippling my user experience. Most of the tools now, they do that optionally. They don't turn indexing off by default, but that's exactly the sort of thing, thanks Hugo, that you should watch out for. So that's the sort of the general difference between Windows 7 and Windows 8. Hugo's now going to dive into the individual applications of the life cycle of Windows 10 and how that sort of affects your storage and the things that you should watch out for in terms of storage.
Thanks, Jim. So a day in the life of a I guess optimized Windows 10 VM. So this exercise is pretty much deploying a vanilla Windows 10, installing Office applications, Adobe Acrobat Reader, and so on, and looking at the performance of that VM on an uncontested Atlantis USX, well, actually Atlantis Hyperscale data store. So we're trying to give this virtual machine as much I/O as it needs, and then also capture the kind of performance characteristics that occurs to this VM. So let's delve into some of these graphs.
So just a quick point on that. the reason why we're trying to give the VM as much I/O as it needs is because it's impossible to measure IOPS requested. Now that's what we really like to know. We really want to know how much Windows is asking for. It's only possible to measure IOPS delivered. So by giving it an uncontested environment, we're trying to make sure that IOPS requested and IOPS delivered are as close as possible, so it gives us that number that we want.
Yeah, so good. So this is a VM again running on Atlantis data store, so pretty much unrestricted performance. So let's boot the VM. You see it boots in pretty much very fast time. So this is the first boot really. So it takes about 3 to 4 seconds to boot, and it's pretty much ready to log in at 7 seconds. Okay, so you see here that Windows 10 at boot time requires around, at peak, 800 read IOPS, but not many write IOPS, right? So at the write IOPS peak, I guess that's about 30 to 40 IOPS. Not much at all.
So there's an interesting thing about this, right? And although I said that in general Windows 7 and Windows 10 were almost equal in terms of IOPS demand, boot is the one exception to this. Mice have been very efficient reducing the amount of reads that Windows 10 needs to do over Windows 7. So it's much easier on storage in terms of boot. Now, whether we care about that or not is up for debate because you can pre-boot all your VMs, etc., etc. But this is the one area where there is a massive difference between 7 and 10.
Thanks, Jim. So let's take a look at login as well. So the same chart, just extended up to 30 seconds this time. You see the same boot and login, and we begin login at around 10 seconds. So the login, you see that there's a lot more read I/O than write I/O, and then things start to become idle after around 18 seconds, and then another read peak at around 22 seconds. So the login in terms of Windows 10 requires more read IOPS than write IOPS, right? Which would make sense because it's reading quite a lot of data. So yeah, sorry about that, guys. So launching off the Office applications here, you can see that the majority of the read of I/O is coming from read. So this is a manual launching of Office apps. So pretty much I logged into the VM and launched Outlook, Word, Excel, PowerPoint, and so on. And then you can see that, of course, obviously, when you're launching apps, it's mainly having read I/O. So Office apps on Windows 10 don't actually require that much I/O. So you're looking at about 34 I/O at peak, right? And very few write I/O as well. Now, does that work? Did that change the screen?
Yep.
Excellent. I'll just carry on from here then. Here is the antivirus scan for, this is the full disk scan on a Windows 10 VM using two different AV. First one is the default Windows Defender, and then the second one is disabling Windows Defender and then installing Avira. So as you can see, antivirus has a major impact on your desktop environment. Okay, lots and lots of read I/O, and antivirus will pretty much consume as much I/O as your storage can give you. So if you look on the right there, Avira would at peak take up to 2,000 I/O. On average, probably about 1,000, maybe just under. And Windows would take up to 1,000 and average maybe 400 or 500 I/O. So what does this mean? So this, remember, this is just one single VM, right? If you did this at scale on your entire infrastructure and scanned everything at the same time, what do you think is going to happen to your underlying storage? It's probably going to burn up. So how do you mitigate some of this? Now, AV vendors nowadays, you can, some say offload it to the hypervisor, for example. Some have antivirus applications that are tuned to virtual environments, which is quite a good approach. And I guess we should have done a poll for this, but the majority of people, I believe, seeing in the field out there, just have standard AV as they would in the physical world running in a virtual machine. Now that's pretty bad, as you can see, if you have like 1,000 users using just Windows Defender, all scanning at the same time, that's really going to have a big impact on your underlying storage. So that's going to cause a major issue. And I think AV is the key application that you need to look out for when planning your environment. So that's just not for Windows 10, it's also, of course, for Windows 7 as well. Automatic updates. Now, automatic updates, this is the default. I didn't change anything. So if you didn't change your image, right, you haven't tuned it, then you're going to have a big problem, because Windows 10 at boot time, it would always check for updates, right? So that initial check would incur some I/O, and when it does check and it starts to download, if you didn't change that, then it will start to consume quite a lot of read I/O, as you can see. But in this case, with Windows updates, when you download updates, it needs to write those somewhere as well. So you can see that peak at around 400 IOPS. Big one is that large peak for 1,300 read IOPS. Now this is, of course, again for just a single virtual machine. Okay. What if you had, 100, 500, 1,000 desktops running? Then you're going to have a big problem. So you need to look at your Windows updates settings, maybe set a group policy, for example, to prevent that from being downloaded. Okay. I know, in enterprise environments you have other things, other update methodologies to use. I suggest you use those as well. So automatic updates are very read heavy, peaking at 1,200 IOPS, as I said, and key takeaway is just to pretty much make sure you check that. So with let's talk about login VSI now. So this is a login VSI knowledge worker. So that's a VM configured with 2 GB of RAM, 2 virtual CPUs, and Office. And login VSI knowledge worker runs quite a few things, right? So we kick it off at 0 seconds, as immediately you see write and read IOPS is very high. So the first peak you see here is it launching Outlook and then running PDF creation printing. So that PDF printing creates incurs around 120 IOPS of write and read to do, right? Then you have quite a lot of other mini activities, web browsing. You have a large read peak at 180 there. I believe that's opening the PDF. Then you have like other things going on. So you have web browsing, for example, opening PowerPoint. The idle bits you see is when you see the login VSI going, the actual worker pretending to be a worker, going to get a can of Coke, or making a cup of tea, or talking to other people. So you see that this is the first time we see that write IOPS actually, on average, is much higher than read IOPS. Okay. So VDI in this instance is very write heavy with occasional read peaks. So let's look at logout. So logout activity is interestingly more write intensive than reads, right? So you're updating profile files and so on. So that makes sense. And what about shutdown? So shutting down a VM shuts down very quickly, and you see that again it's a lot more write IOPS, but not that much. It's not actually peaking at about 58 IOPS, with some read IO as well. Yeah, I didn't talk about latency much, and Jim's going to talk about latency and take you into the deep crevices of what latency means. Thanks, Jim.
No problem. On my screen, I'm still looking at the login VSI slide. So hopefully everybody else can see the other slides. So
I've given you control as well, so go ahead.
All right. What side are you looking at your side at the moment, Hugo?
Well, I'm doing the screen sharing, so it's the latency slide. Okay. I wonder what everyone else is seeing.
I don't know.
Yeah, they see latency.
Okay, perfect. So latency is really important. So the major core, well, the reason why everybody talks about IOPS so much, right, is actually because IOPS is the major cause, the lack of IOPS is the major cause of latency to your desktop in terms of storage. So latency is actually the most important thing, not IOPS. You can have a lot of latency problems that are not specifically to do with performance on your storage, And the most common cause is effectively queues. So the more layers you have in between your desktops and your storage, then that means more chance for queues. That's a common computer science thing, right? You makes you, if you've got too much demand for your resource, you end up with a queue. So be very careful around queues and the stuff you've got, which is why I kind of like the sort of hyper-converged model, local storage, because it means that you're avoiding all of these little layers in between. You're avoiding the potential for queues. So let's advance that slide if I can.
Applications.
So this is why latency is important. It's because a lot of people judge their speed of their desktop on how fast their apps open, how fast they log in, and the ability to deliver against these peaks of applications is really important, because without being able to service this large demand, it means that your users are going to have a bad impression of the desktop. And this is why you don't do stuff like size and average. You need to ensure that for a snappy, responsive desktop, you need to keep that latency down, not just while the demand is low, but also while the demand is high as well, because that's essentially where your performance comes in. So a very broad rule of thumb is that it takes about 2,000 IOPS before disk is no longer the bottleneck. And we saw that in the day in life slides where you had occasional processes that were peaking up to about 2,000 IOPS. I am not suggesting that you need to spend all that money to give every single desktop 2,000 IOPS. But this is the sort of number that you need to keep in mind, as if you wanted to get the kind of performance that you're going to get that you would do on a local laptop that's got a dedicated solid-state disk. Now, again, what I mean by that is you've got to accommodate the peaks. So you've got to make sure that you do your sums correctly, and that when you're looking at the demand over time and over day, that you're able to service these peaks and allow the desktop and the applications to consume that much. Next slide, please, Nate. And there are a couple of architectural solutions that can help, right? One is the non-persistent delivery of VMs. So link clones, PVS, MCS will traditionally help to a certain extent in terms of storage capacity, enabling you to use less of faster storage, or in the case of PVS, in fact, offloading some of that storage either over the network to the RAM on the PVS server, or even to RAM on the local VM as well. Fast storage, massively important. The reason why all new laptops have SSDs, everything is now flash, because it's really important, and disks are really crap. 10G networking, particularly as you scale out. So for instance, PVS, a 25 VM boot will saturate a 1 gig network. So you can imagine what happens as you try to scale out in terms of network bandwidth as you're looking at that kind of solution. New hardware, it sounds silly, but the difference between a G7 and a G9 is massive. You're looking at about a 40% increase in user experience when you're going a couple of steps up, even with the same processor clock speed and the same amount of RAM, if you can afford it. And I know this slide is saying spend loads of money, but try and figure out where the bang for the buck is, and new hardware will give you a massive bang for your buck. The free one, almost free, is make sure your power settings in your BIOS and your hypervisor are set to max performance. It makes a huge difference in terms of your user experience in VDI. I'll hand it back over to you now, Hugo.
Thanks for that. Okay, Jim. So just to, you've heard about us talking about the Windows 10 characteristics within VDI. I just want to spend a couple of last minutes going through I guess the Atlantis Value. So I think some of you are long-term supporters of Atlantis, your customers, your partners currently, and I guess we just want to spend some time talking about the key differentiators with the Atlantis software. So you see some of the testing that we did. We used the Atlantis backend to provide Windows 10 with all the I/O and very, very low latency that it requires to get those graphs out for you, right? So if we used, slow disk or slow NAS array, we wouldn't be able to get that 2000 IOPS peak that you see in some of the graphs. So with the Atlantis piece, company, we were founded late 2006 we're based in Mountain View. That's where I'm based as well. Currently, we have around 150 employees. Now, the key things about our technology is we have these patents, and also with a couple of patents pending, primarily around the inline deduplication, where we have that storage in memory. So that VM that we're running all those tests was pretty much running in memory. Okay. We have automated tiering of the RAM and flash when we're using flash as a persistent storage tier. And we have a very special code that understands content-aware caching. So things like Windows 10 operating system kernel files, all of those recently seen files are always running in RAM, right, on the storage, so that you can have very, very fast performance for logins and shutdowns and so on. We also provide hyper-converged systems as well. So we make running VDI within a remote office, branch office, or server virtualization workloads much more efficient than anyone else. And we do that by driving down the cost of performance, because we're using these clever technologies to do that. We have major customers in hospital, healthcare, banking, and government agencies. And we help IT organizations gain all-flash performance across their entire data center, up to 50 to 90% lower hardware costs. So because we're doing all the deduplication and so on, we're you require less actual storage hardware to run all those many VMs. So for example, that 1500 login VSI test, that didn't consume much storage at all, because if you look at a Windows 10 VM image, the majority of that data, all the Office files, the operating system files and so on, can be deduped quite heavily. So the actual storage footprint is very, very low. And that's how we drive that cost down. We also have freedom of choice for server vendors as well, and hypervisors. So we support Zen Server, Hyper-V, and VMware vSphere. And because it's software, it's modular, so you can pay as you go along. So agility and performance are the two key drivers. Okay, so we offer that simplicity, if I can talk properly, because data centers are too complex. We don't want IT to spend time dealing with complex issues. Instead, we'd rather have them innovating and automating. We help with virtualization of different types of storage with the software-defined storage solution from USX, and we also have hyper-converged as well with a Hyperscale product. And the key thing here is around performance. So we enable, for example, you to obtain high performance on your current files arrays or NAS or SAN arrays by virtualizing that hardware and providing performance from software. Okay, and that drives the cost per IO and cost per gigabyte down, which leads to better performance and lower cost in your data center. So we do this with the two pieces of products that we have, Atlantis USX and Atlantis Hyperscale. And I've defined some of that. If you want to read more, have a look at our website. We've got lots of information, lots of white papers and so on. And by all means, reach out to myself and Jim. So the key takeaways from today is definitely understand your performance requirements. Test your environment as much as you can by using some of the tools. Now, the majority of those tools are free. Login VSI is, of course, free, up to 100 users. If you need more, then reach out to Login VSI. They'll be very, very keen to help you, test out, define those testing parameters and requirements to test your end-to-end environment out. And that would help you test at scale as well. There's no point just testing one single VM. It's always good to test at scale. Of course, we've sent out the white paper with the presentation as well, with all the technical problems that we encountered today cut out, hopefully. And with that, let's take Tim, any more takeaways before we move on to QA?
No, I think we've covered most of it, and I'm pretty conscious that we're at the top of the hour as well. I think most of the questions that have been asked have been answered in the chat. There was one question on Windows Update, which I have no idea on actually, which is restricts Windows updates P2P only to local network recommended. Hugo, do you have an answer for that? Because I have no idea.
I'm actually trying to look at the question. I can't see that question. Can you say that again?
Restrict Windows Update P2P only to local network.
Oh yes, yeah, point to point. So you run some type of, for example, WSAS server or something else internally, that downloads all the updates, and then you push that out internally local to the network. But that doesn't take away the I/O requirement on the storage on the individual virtual machine, right? Because you're now, not all VMs will go to the internet to get that update. They'll go to a local server somewhere. But when they do that, they'll still be downloading and actually running the update locally on the storage. So the graph where I showed with the I/O on storage, you'll still see that even if it's local. You'll just remove that network component.
So the answer to that question, we've had a few people actually in chat saying not recommended, disable P2P. So there you go. We have extremely knowledgeable audience as per usual.
Awesome. One more question that came up earlier, probably one for you, Jim. Where is that one? A question, this was asked advanced by Boris. Do we have to keep something in mind as we migrate from a mandatory profile version 2 to version 3?
I did answer that in chat, so.
Okay. Okay.
I think that'll do us. Thank you very much, everybody who's attended. Apologies for the issue with the GoToWebinar. Hopefully, it didn't distract from the presentation too much. If you've got any further questions, feel free to email or tweet at me or Hugo. And as Hugo said, you'll get all the resources in an email very shortly after this. So thank you very much.